Okay, so in this video we're going to do more examples of factoring trinomials using what I call the AC method. Or not the AC method, I'm sorry. Well, it's sort of like the AC method, but this case, all we're doing is using the factors of the constant term meaning these terms here, okay? And we'll get to this one last, but this doesn't have a constant term. So these two do have constant terms. And so we want to find two factors of the constant term that add up to the middle term, okay? That's the key. So again, all of these start with 1 as a leading coefficient, okay? So let's look at this one. So again, we want to find two factors of -8 that when added together give us 7. Now here's the thing. We may have to go through some factors, okay? It might not come to us. And sometimes we may have to list out all the different possible factors. Now, if this is negative, in order to get a negative number, we have to have two factors that are opposite signs. Which means when you add integers that have opposite signs, you have to subtract them, okay? And so that means you have to look at the middle term to see which one is going to be the positive or negative value. So in this case here, here's the technique. Since this is negative, the factors have to have opposite signs. But they have to add up to a positive 7, which means when I subtract the two numbers, the larger number has to be positive in order to get a positive number, okay? So, for example, if I do 8, I can have, for 8, right? Oops, let me do it this way. For the factor pairs, for 8, I can have 1 and 8. I can have 2 and 4. Okay? And those are it. Those are only factors. So, but which one's negative, which one's positive? Well, I could have these be negative, but the other ones could be negative too. So that means I'm going to have to repeat these. Where these are negative. Okay? So that gives me a total of 4 possibilities. And so what I have to do is I have to pick the pair that gives me positive 7. And the only one that gives you, and there will only be one, if there are any. You might do this and there might not be any, okay? And if you go through the process and you don't find any factors, then that means it's not factorable. Okay, it does not factor into integer factors. Okay, so now that's the pair that does it. So that's what we're going to do. So this means that this factors into x minus 1 and x plus 8. Now, let's do the next one. Again, notice that this here is negative. So that means the factors are going to have opposite signs because that's the only way you can get a product that's negative. It has to be opposite signs. So let's do 12. So negative 12. So what are the factors of 12? I can get 1 and 12, 2 and 6, 3 and 4. And since it's negative, either these have to be negative, or if I repeat it, these have to be negative. And again, now, looking at the middle term, I see the middle term here is negative, which means the larger number has to be negative. That'll help us. Why? Because that means these are out. can't be any of those. Okay? So it has to be one of these if it's going to be any of them. And so now we want a negative 1. So now here's the other thing too. Listen, this number is small. And since this is negative and they have to have opposite signs and we're going to be subtracting the two factors to get this, they're going to be close together, right? The difference between the two numbers is small. So that means they're going to be close together. So that one's this one. So, and this one works. So just little tricks to keep in mind to help you navigate some of this stuff. And so now this factors into x plus 3 times x minus 4. Okay, now what about this one? Okay, let's take a look at this. Oops. So remember, I've got to have this factor here and a factor here. So now notice in this one here, we've got x squared. Okay? And we've got a y squared here. And we've got a product of 2 here. So notice that in order to get an x squared here, the only way I can get an x squared here is if I have an x here and an x here, right? Look at the x squared here. Look at the x squared. X, x, x squared, x, x, right? That's the only way I can get x squared here. Now, the only way to get y squared here is if I have y here. Okay, now listen, this is positive, which means that tells me that both of the factors need to be positive or both of them are negative. Now, the middle term is negative, which tells me that both have to be negative, right? Because in order to add to a negative number, they both have to be negative. Okay, so notice that the cross multiplication gives me my xy, so that's not an issue, okay? The issue is I got to figure out what the middle term looks like, and that can be a bit challenging, okay? Now, and in this case here, there's no way to do it. And the reason why is because this is 1, and there's no factors that are going to give me a middle term of 5. Okay? So in this case, it doesn't work, because there's no factors here that will give me a sum of 5. So this is not factorable. Now, what if I do this? Okay, now, so everything's fine, but what if I change it to this? Okay, now, again, they both have to be both positive or both negative, and they have to be both negative because this is negative. And the only factors of 6 that will add up to a negative 5 is a negative 2 and a negative 3. So guess what? The factors, again, the factors of this are going to be what? 2y and 3y. So guess what? This is going to be plus 2y plus 3y. So it still works because look, if you add these up, you get these, right? Oh, hold on a second. Yeah, that's right, that's right. Because if you add the 2 and the 3, you get the 5. And the only difference between the other ones is that we have a y squared here, and that's where the y and the y have to go there. And again, FOIL this out to verify and prove it to yourself that this works. Okay? So it even works with situations like this. Have a great day.